Video, we're going to continue where we left off in the last one. In the last video, we were talking about tangent graphs. And in this video, we're going to talk about some reciprocal functions. So we're going to start with the reciprocal of tangent. That's called cotangent. If tangent was defined as sine over cosine, then cotangent must be the reciprocal of that. So instead, cotangent is defined as cosine over sine. Other ways we could think about it, though. Cosine functions give us x values. Sine functions give us y values. So we could say it's x over y. Or we could simply flip tangent and make it a reciprocal and say cotangent is 1 over tangent. So a few different identities there for cotangent. In our cotangent ratio, y is in the denominator. And if the denominator is ever 0, we have undefined values. So if y is 0, cotangent is undefined. So if you think about a graph where y values are 0, that's on the x-axis. So we're going to hang out on the x-axis and be in intervals of pi. So here I could start here on the x-axis. I could really talk about any values in between until I get all the way over to the other x-axis. So that's an interval of pi. Just a half circle. And what's going to end up happening is when we get to the ends of those intervals, we're going to hit asymptotes. And so your asymptotes can actually be found by just finding intervals of pi. All right, let's graph the most basic cotangent function here. So the period is pi. So if I do pi divided by b, the exact same as what I did with tangent, I can get my period length. In this case, b is 1, so pi over 1 is pi. So our period length is pi long. And then intervals from there, if I add pi or subtract pi, I could do that as well. I'm going to get to asymptotes. So if I subtract pi from pi, I get 0. If I add pi to pi, I would get 2 pi. If I kept moving left from 0, I would get to negative pi. So any intervals, and every time I add pi to my period, I'm going to see a vertical asymptote occur on my graph. So notice for the basic cotangent function that 0, an x value of 0, is going to be an asymptote. That's the y-axis. So without shifting, cotangents are going to have an asymptote at the y-axis. And from there, any multiple of pi is going to be another asymptote. So I can plot my asymptotes along the y-axis and pi. I could add more if I want. I could put one at negative pi. Usually, though, we only need to plot or graph one period here. Midpoints for cotangent are going to act a little bit differently. Rather than being points that are off the axis, now your midpoint is going to be on the x-axis. So your y value is always going to be 0, again, if we're not shifting any. Midpoints are still half of your asymptote, whatever half of your x value of your asymptote is. So half of pi would be pi over 2. Obviously, between 0 and pi is pi over 2. So that's going to be an intercept now for our cotangent function. I drew or sketched in tangent here, although I should have taken it out. I don't want you to think that tangent and cotangent are flipped along that midpoint or symmetrical along that. They are not. Cotangent is actually shifted away from the tangent graph. They don't have asymptotes that line up. So the only reason I put that there is just to show the behavior is the opposite. So rather than for tangent going up from left to right, cotangent is going down from left to right. Otherwise, ignore that tangent graph because that's not really the relationship between those two graphs. Take a look on a calculator or use that website Desmos to compare those two graphs so you can see how the cotangent graph shifts away from the tangent graph a little bit. All right, but there's basic cotangent graph. The period interval is going from one asymptote to another. So the initial one here would be from 0 to pi. Don't include your or equal symbols there because we're not including values on those asymptotes. Let's do another one. This time we're going to increase our amplitude, not altitude, although it's similar, and our vertical stretch. Sorry, horizontal stretch. Get my act together here. Pi over b is going to be the period. Since our period, we can shift that fraction out in front, so the b value is 1/3. So pi divided by b is going to be pi divided by 1/3. Dividing by a fraction is multiplying by its reciprocal. So pi times 3 gives us 3 pi. That's our period length. So again, without any shifting, we're going to start our asymptote at the y-axis, and we're going to go 3 pi across, and there's our new asymptote. We can go to the left of 0 if we wanted. At negative 3 pi, that would also be an asymptote. Another way that you can come up with your asymptote equations is take whatever in your parentheses, set it equal to that interval of pi. So multiply both sides by 3, and now we can see that asymptotes are going to occur at x equals 3 times whatever interval of pi it is. So if n is 0, then x would equal 0, and so notice we have an asymptote there. If n is 1, then 3 times pi is 3 pi. There's an asymptote. If n was 2, that would be 3 times 2 pi, which would be 6 pi. So another 3 pi later would be another asymptote. So you can see that interval of 3 pi giving us our asymptotes. If that's our period length and we cut it in half, we get our midpoint. So 3 pi divided by 2 is 3 pi halves. Knowing that that midpoint is going to be on the x-axis as long as we're not shifting at all. Knowing that the cotangent graph goes down from left to right. And there's our cotangent graph for this function. Period interval in between your two asymptotes, starting with our initial period here from 0 to 3 pi. So there's cotangent. Let's get into secant and cosecant graphs. Another thing you might want to do is compare cosecant and sine graphs to see how they relate. You can do the same comparing secant and cosine graphs. They're going to look very similar. The reciprocal compared to the original function, I mean. Start with cosecant. Cosecant can be defined as the reciprocal of sine. Sine functions give us y values, so the reciprocal of that would be 1 over y. Because we have a ratio, we can have a 0 in the denominator that makes it undefined. So if y is 0, cosecant is undefined. So again, we're hanging out where y can't equal 0, which is very similar to our cotangent, where we said that y couldn't equal 0. Notice that the intervals of our vertical asymptotes were intervals of pi. So cosecant is going to have similar behavior in that it's going to have asymptotes wherever we have intervals of pi. So as far as asymptotes go, cosecant and cotangent are related in that they have asymptotes at intervals of pi. The period of cosecant, though, is similar to that of sine, which has a period of 2 pi. So 2 pi over b is going to give us our period length. We'll graph cosecant in a minute. Let's talk about secant. Definition of secant is the reciprocal of cosine. Cosine gives us x values. So secant would be 1 over x. So in that ratio, x cannot be 0, otherwise we're undefined. If we think back to tangent, Tangent had a similar thing where x was in the denominator and undefined values of tangent were where x was 0. So our asymptote is going to follow the same behavior as the tangents in that it's going to be intervals of pi over 2 plus some multiple of pi. So secant and tangent have similar definitions of their asymptotes. All right, the trick we're going to use in this video is we're going to graph sine and cosine, and that's going to help us graph cosecant and secant. What's going to end up happening is that the minimums of cosine, or these valleys here in our cosine graph, are going to turn into hills. And hills of our cosine graph are going to turn into valleys. So let's practice. Let's do a secant graph here. In order to do secant, we're going to graph cosine. So secant of 2x is going to be the reciprocal of cosine of 2x. Let's graph cosine of 2x, and that will help us graph secant of 2x. For the cosine graph, our amplitude is 1, that a value in front, which means that the max and min of that cosine graph is going to be at 1 down to -1. The period length is 2 pi over b. Our b value in this case is 2, so 2 pi divided by 2 is pi. So because we haven't shifted left or right, our graph is going to start at x equals 0, and it's going to go pi long here. So we could count off 4 intervals ending at pi, and we could work our way back and identify our interval lengths here. Half of pi is pi over 2. Half of that is pi over 4, so our intervals are counting by fourths. So 1/4, 2/4 is a half, 3/4 here, and 4/4 getting us to a full pi. So there's our key points. We can plot cosine by starting at the maximum value, going to that midline in between our max and our min, next down to the minimum, back up to the midline, and back up to the maximum. So from there, hopefully when you were comparing some graphs up here, you were noticing that the x-intercepts of sine and cosine are turning into asymptotes for cosecant and secant. So where we see x-intercepts here in our cosine graph, I'm going to put my asymptotes at those points. And then I'll take a look here at this little hill that's going down on our cosine graph. That's going to turn, hill. That's going to turn into a valley, or give it a bump, and it's going to go up. So the direction is going to be the opposite there. Here, because we have this valley here, we're going to do a hill-ish shape in between those two asymptotes. So opposite behavior there. And then over here, we got this half of a hill here, so we're going to draw half of a valley going in the opposite direction. You can imagine that those graphs are going to continue and just repeat. Since we already have the right side over here, we don't want to draw it over here. That would be more than one period. So the period of a secant graph is a little weird. It's got kind of half of a graph here, more of a full upside down graph there, and then another half over here. So in looking at the cosine graph and seeing our intercepts, we knew where our vertical asymptotes would happen. And our period interval is going to be broken up a little bit here. So the first part of our period goes from 0 to pi over 4, then we hit an asymptote. Then we go from pi over 4 to 3 pi over 4, then we hit another asymptote. And then we go to from 3 pi over to pi before our graph repeats. So there's our secant graph. All right, let's try cosecant. Cosecant is going to be the reciprocal of sine. So if I graph my sine function, I'll be able to work with that. Graphing the exact same thing here, but just calling it the sine function. My amplitude is 2 in front, meaning that my max and my min are going to go from positive 2 on top to negative 2 on the bottom without any vertical shifts. Period length is going to be 2 pi divided by b. Our b value in this case is 1, so 2 pi divided by 1 is 2 pi. But because we have this horizontal shift, we're going to take that period and we're going to combine it with a phase shift here, or horizontal shift, to come up with our period interval. So this is going to give us the left endpoint and the right endpoint of our sine graph. We moved left, or shifted left, pi over 4 units. That's going to be my new left endpoint. If I combine that with 2 pi, I'll get my right endpoint. So taking that period length and combining it with my shift. So negative pi over 4 plus 2 pi. Well, 2 pi is 8/4. So if I just take 1 away from 8/4, I get 7/4 pi. So there's the right endpoint of my graph now. If I take that interval and I break it up into 4 parts, 4 equal parts, well, half way between these 2 points, I can use a midpoint formula on if I combine these endpoints here. Negative 1/4 plus 7/4 is 6/4. If I take 6/4 and I divide it in half, I get 3/4. So take your endpoints and divide by 2, that's the midpoint formula. That's how we find the middle of something. Taking that endpoint with my left endpoint and finding the middle of that, again combining those values, negative 1/4 plus 3/4 is 2/4. If I cut that in half, I get 1/4. So now I can see that 0 is going to happen in between those 2 points. So I can go ahead and put my left endpoint just to the left of 0, right endpoint just to the right of 0. I have one more point, one more key point that I need here. That would be the middle of these 2 points. So 3/4 and 7/4 combined to make 10/4. And if you divide that in half, you get 5/4. So there are my key points for my sine graph. Without any shifts vertically, I know that I start on the x-axis. Although another way to describe it is starting at the midline, so halfway between your min and your max. Halfway between 2 and negative 2 is 0, so I'm starting on the x-axis. It then goes up to my maximum, then to my midline again, down to my minimum, and then back up to the midline. So there's our sine curve. Again, if we take our intercepts and make them asymptotes, those will be the asymptotes of the cosecant graph. Taking this bigger hill and flipping it to make a valley, it's going to be half of that graph. Taking this valley and making it a hill below it gives me the second half. So there's our cosecant graphs. Period interval for this one in particular would be from our left endpoint, which was our first asymptote, over to our next asymptote at 3 pi over 4. And then starting from 3 pi over 4 over to the next asymptote at 7 pi over 4. Gives us our period interval for this particular graph. So that's cosecant. Graph your sine function. Turn your intercepts into asymptotes and flip your hills to valleys or valleys to hills. For secant, you're taking your x-intercepts of your cosine graph and turning those into asymptotes, and again flipping your hills to valleys or valleys to hills. All right, a little tricky takes a long time to do, but with practice, you'll get the hang of it. Good luck practicing graphing those reciprocal functions.